Right, so we're going to go ahead and begin with 5.2, and we're going to start with question number 3. And these are trinomials because they have our 3 terms. And we have a minus x squared plus 5x plus 24. So this is where we're going to begin in 5.2 with this question. Now, the very, very first thing that we need to look for is we need to see if we begin with a negative, which in this case, it begins with a negative. Okay, and any time your trinomial ever begins with a negative, you've got to factor that negative out. So we're going to take that negative out, and that just makes it easier to work with. And when you factor out a negative, what that then does is that then switches your sign. So if it ever begins with a negative, the first piece is negative, take it out. All right, so once that's been taken out, then we can factor our trinomial. And there's no number in front of the x squared, so we know there's a 1 there. So then we take 1 times a negative 24. And that makes it a negative 24. And we place that in the box. Now, let's remember our signs. This is actually called Descartes' rule of signs, how these work. This is negative. So, what does that tell you? That tells you then that 1 is positive, 1 is negative. Why? Because how can you get 2 numbers to multiply together to give you a negative? One of them has to be positive, one of them has to be negative. So this number in this box is negative. 1 is positive, 1 is negative. Now, how do we know which one's bigger? Well, we look in the middle. And in the middle, the sign is negative. So that tells me then that the larger number is negative, smaller number is positive. Now we need to find our 2 numbers. So we need 2 numbers that are going to multiply together to give you 24, subtract from each other to give you 5. Okay, well, 24, where are we going to begin? Well, let's begin with 3. Okay, if we use 3, we've got 3 and 8. And what's 8 minus 3? 5. That's what we want in the middle. So we need a negative 8 and a positive 3. And it's just a matter of trying different numbers until you find it. How can we check? Well, negative 8 times 3, negative 24. That's the number in the box. Minus 8 plus 3, negative 5. That's the number in the middle here. So we know then that we have it ready to be broken up and factored by grouping. So now we can go ahead and split this up. Okay, we split the middle up, so we've got an x squared, stays the same, right? And our minus 24 on the end also stays the same. What are we doing? We're splitting up that minus 5x, and we're going to split that up into minus 8x and a plus 3x, because minus 8x plus 3x is a minus 5x, right? See how it all kind of goes together. Now what do we do? Okay, now we go ahead and factor by grouping. So first 2 pieces, we can factor out an x, right? And that leaves you with an x minus 8. Next 2 pieces, we can factor out a 3. That leaves you with an x minus 8, right?
Caitlin's here.
Okay,
She's
yep.
in the bathroom.
Okay, I'll go ahead and mark you off as both being here.
Sorry.
Oh, hey, no problem.
These are here.
Yep. Okay. All right. Yep. Okay, so let's now go ahead. We're factor by grouping. We're on question 3. And what did we notice here? Are these groupings the same? Yep, they are. Okay, so that then leaves you with an x minus 8. Gone. Gone. What's left over? X plus 3. And what's out in front of all of it? Negative. So that's going to be your final finished answer there for question number 3. So on that one, what we had to do was we wanted to make sure we factored out that negative first. Whenever it begins with a negative, we always do that. Factor your negative out first. That's going to switch your signs around. Then factor it, split up the middle, because we have our 3 terms. Split it up, make it 4, and then factor it and finish it from there. Question 10 out of 5-2 is one of the more difficult ones. Okay, I only gave you one of these. And we're going to learn how to factor this one today. We talked about one of them last time. Okay, we did one similar to this last time. These are difficult just because there's a lot to keep track of. So first off, I count the number of terms. So I've got 1, 2, 3 terms. Now, terms, the number of terms tells us how to factor and how to work with these. So we have 3 terms. So that tells me then that I take the first times the last. And the first times the last, 10 times 10 is 100. Okay, is everyone all right with that so far? Okay, first times the last is 100. Now, what do we know about the sign? 100 is positive. So we know they are the same signs. Okay, what's the sign in the middle? Positive, so that means these are both going to be positives. Now, what do we know about 100? 100 ends in a 0. That means it has to either have a factor of 5 or 10 in it. So we would try multiples of 5 and multiples of 10. What happens if we try 5? Well, if we try 5, we've got 100. Right? Divide that by 5, what do we get? 20. Okay, we're pretty close to that 29, aren't we? Not too far off. Because 20 and 5 gives you that 25. We do need to go a little bit further. 10, okay, if we do 10, 10's not going to work. Because 100, divide that by 10. 10 and 10 makes it 20. We need that 29. Let's try 15. 15 doesn't go in there. Okay, what about 20? Well, we did 20 a minute ago, right? Because that's 5 and 20. What about 25? Okay, let's check 25. If we take 100 and we divide that by 25, what do we get? 25 and 4. That's it, because 25 and 4, that adds together to give you what? 29. See how I got the pattern? Where did I begin? Now, you could have just looked at this at the very beginning and said, okay, this ends in a 0. I'm going to start with 25 and figure it out from there. I chose to go through all the different numbers to try to find it. Once you get good at these, you can normally see them ahead of time. But I looked at this and I said, okay, 25 and 4 work because that breaks up into 29. Now we split it up. We need to be careful when we do this, though. So we have 10 p plus 1 quantity squared plus 25 p plus 1 plus 4 p plus 1 plus 10. So we split it up, and now we are going to start factoring it by grouping. Okay, and so the first two pieces, let's look at the numbers out in front. We have we have a 10 and we have a 25. So 10 and 25, they have a 5 in common. They also have a p plus 1, so that's going to come out. You can use parentheses again, or you can use square brackets. I'm going to use square brackets because we have lots of parentheses here already. So just to make it a little bit neater, I'm going to use a square bracket here. Okay, 10 divided by 5 is 2. This is squared. We took one of them out, so that leaves you with a p plus 1. 25 divided by 5, that leaves you with the 5. And the p plus 1s are gone. Now we repeat the process on the next two pieces. And so 4 and 10, well, 4 and 10, they have a 2 in common. That's going to leave you then with 4 divided by 2 is 2 times p plus 1. And 10 divided by 2 is a 5. And again, this is one of the more difficult problems that we have, just because it's hard to keep track of everything. So we're at this point. Okay, now we need to clean this up a bit, combine things together. So let's go ahead and clean these up. And we can clean it up over the side if we need to. These are the same though, right? And what's 2 times p plus 1 plus 5? Well, we'll distribute that 2 through. So that's going to be a 2p plus 2 plus 5, which is then a 2p plus 7. Okay, so that takes care of that. These are the same. This is what's going to come out, right? Because these are the same here. So that's going to come out as a 2p plus 7. Because that's what that condensed down into. And what's left over? 5 times p plus 1 plus 2. Okay, and almost finished. We can do one more step here. What do we need to do? We need to clean this up. How do we clean that up? We distribute and combine. So we'll distribute that 5 through, and that's going to be a 5p plus 5 plus 2, which is then a 5p plus 7. And that broke down into the 5p plus 7. And that's going to be your final finished answer on that one. And that one was just kind of difficult to keep track of all the pieces. So again, let's kind of review what we did. At the very, very beginning, what did we do? We counted the number of terms. We had 3 terms. So that means we took the first times the last. We put the 100 in the box. 25 and 4 works. We split the 29 up. We then factored out by grouping what was in common. This one then, we had to do a little bit of work. We had to simplify these brackets down using the distributive property and combining like terms, which we did there. Okay, that gave you that piece. Then we got to this point, because that's gone, and that was gone. And then we had to distribute the 5 through, and add the 2 to it to make it the 7, which cleans up this piece. That one was just hard to keep track of all the different components. 2 more out of this section. So we're next going to look at 20 and then 21. So question 20 here. This is another factoring one. Okay, now question 20, we need to see what we can take out at the beginning. $20 looks way more complicated than what it truly is. And it's easy to look at a question like 20 and think, this is going to be a really difficult question. And it's really not. Okay, because the very first thing that we do before we start making the box and putting things together is we look at all the terms together and we see what they have, if anything, that's in common. All of these, in this case, have A plus B, right, quantity squared. So that's going to come out because it's in all of them. Now, what's going to be left over? Well, what's left over is a squared minus ab minus 20 b squared. I'm not going to work this one completely out, but I will get you to the factor by grouping step, and then you should be able to finish it from there. So we'll do a couple more steps, and then I'll leave it for you to finish. So there's no number in front of the a squared, so we're going to put the 1 here. And 1 times a negative 20. 1 times a negative 20 is a negative 20, so that goes in the box. Okay, let's remember our rule for the signs. The 20, the number in the box, is negative, so that tells me then one number is positive, right? One number is negative. We look in the middle. Sign in the middle is negative. I always put the larger one first. Okay, now what does 20 end in? 20 ends in a 0. So we're going to start with 5. Okay, 20 divided by 5 is a 4, right? And what about 5 minus 4? 1. And isn't that what we want here? Yep, we want a minus, okay? So we're going to use a minus 5 and a positive 4. Multiply them together, you get the minus 20. Subtract them from each other, you get the minus 1 in the middle. I'm going to split that up, and you can finish it here. So I split this up into the last part, which what are we going to do? Factor by grouping. So you group those two together and those two together. You should be able to factor it by grouping pretty quickly, and then don't forget to bring this down. So don't forget to bring that down when you're finished. Okay? Because you should be able to factor that pretty easily. It's mostly done for you already. 21. When we look at 21, we're going to look at all the parts put together, and we're going to see if something can factor out first. These numbers all look pretty large because we have an 18, we have a 63, and we have a 36. And let's see if something's in common, because I know that the 18 and the 36, they have a 3 in common at least. Let's see if 63 has a 3 in there as well. Yep, it does. Okay, so 3 will work. Let's try a 6, because 6 is an 18, 36. Let's see if it's in there in that 63 as well, and it's not. Okay, so I don't think we can do 9. Let's double check with 9. Yep, we can do 9. Okay, because 18 divided by 9 is 2. 36 divided by 9 is a 4. So you always want to take out the largest possible number. And largest possible number is going to be a 9. So I'm going to take out a 9 here. 18 divided by 9 is a 2, x squared. 63 divided by 9, that's going to be a minus 7x. 36 divided by 9, well, that's a minus 4. Now the numbers look dramatically easier. So again, I'm going to work it out to this point where you can use factor by grouping. So I'll do one more step. We're going to take the first times the last. 2 times negative 4, that's a negative 8. So that tells me then that 1 is positive, one number is negative, sign in the middle is negative. Can someone tell me what 2 numbers are going to work here? Because you need to make sure you can find them. What 2 numbers multiply together to give you 8 subtract from each other to give you 7. Can anyone tell me what the two numbers would be? Okay, here's a hint and where to begin. Look at the number in the box. Look at the number in the middle. How close are they? They're a difference of 1. Okay, well, what about 8 and 1? Well, 8 times 1 is 8, which is what we need there. Right? And a minus 8 and a plus 1, that gives you a what? Negative 7. So that's what we need. So we need a negative 8 and a positive 1. So there are things to kind of keep track of here. These are just puzzles. Factoring is nothing but just kind of a puzzle. And you look for things, you say this is a minus 7 and this is a minus 8. There's only a difference of 1, so my factor has to be a 1. Because they're just off by 1. So now I'm going to rewrite it as 2x squared minus 8x plus x and minus 4. You're going to factor it and finish it from here. So you'll factor it by grouping, and then you'll bring down that 9. And factoring is one of those things, the more of it that you do, the easier it becomes. It's just kind of basically looking for patterns and thinking of it as kind of a puzzle. How can I approach this? What do I need to do? Is there any more out of 5 2 to look at? If not, then we'll move on to 5 3. And we're going to finish 5 3 today. And move on to 5 4. Now, just so everyone knows, we only have a few class periods left. So we have this week of lecture. We have next week, and then we have our final on what I think the 11th. I think it's May 11th is our final. So we've got this week, next week, and then our final exam. So what we're going to be doing this week is we're going to be working through some more out of 5 3 and 5 4. Next week, we're going to come in. We're going to finish up what we need to out of Chapter 5, and then we're going to start reviewing for our final. And then that following week is our final exam. So just a few weeks left. Let's go ahead now and look at some of these questions out of 5 3. And we're going to look at question 4. This is x minus y, quantity cubed, minus 64. When you factor, the most important part of the question is how do I factor? What do I need to do? Where do I begin? Because normally once students start working through a question, it starts to make more sense. But a lot of times students really struggle with, where do I begin? I see this, I don't even know where to start. Because once you get started, you're okay. It all goes back to the number of terms. The number of terms is going to tell us how to factor. This one has 2 terms, right? 2 terms here. And then I look at my exponents, and this is cubed. So that tells me then I have 2 terms, this is cubed, that this is probably going to be a difference of cubes. Because 64 is a perfect cube, right? If you go back to your table, 64, I believe, is a perfect cube of 4. Because 4 to the 3rd power is going to give you that 64. So this is a difference of cubes. How do I know it's a difference of cubes? 64 is a cubed. This is cubed. 2 terms. It has a negative. Okay, so I'm going to leave plenty of room for this one. How do our signs go? Remember, they switch back and forth. It starts with whatever's in the middle. So it goes negative. Switch it then to positive, and you always end with a positive. So it goes minus, plus, plus. Now, where do we begin from here? Well, now we need to think about our cubes. We know that 64 is a perfect cube of 4. So 64 is a perfect cube of 4. We know that this is cubed here. Okay, so we split them up. So what's going to go here is an x minus y, because there's 3 of them. One of them goes here, and an x minus y quantity squared goes here, because you have to make 3 total. Okay, there's one of them here, 2 more. That makes the 3 that we need. Now, what about 64? Perfect cube of 4. So 4 goes here. It's gone. What's left over? 4 times 4, which is a 16. Right? So 4 times 4 is 16. You have to make sure you use all the pieces up. Now, what goes in here? Remember, this is your xy, so they go together. So that's going to be this put together. So that's 4 times x minus y. As those two just get put together in the middle. It's just a matter of working a lot of these out. You get used to the patterns. It starts to make more sense. Now, this has got to be cleaned up. So we're going to have to try to clean this up. We're going to have to distribute, and we're also going to have to FOIL. This piece right here is done. Why is it already done? Well, x, y, and 4, they have nothing in common, right? So that's already cleaned up as much as it can be. So that piece is done. Now for this one, we're going to have to FOIL here, and we're going to have to distribute that 4 through. So I'm going to go ahead and FOIL this out. So that's x minus y, and that's x squared, minus xy, minus xy, negative and negative makes it a positive y squared, and so that's x squared, minus 2xy, plus y squared. What are we going to do with the 4? Well, the 4 has to be distributed through, so that's simple enough. That's going to be 4x plus 4y. This one, again, is just keeping track of all the different pieces. So now let's rewrite what we've got and try to break it down and clean it up if we can. So what do we have now? At the very beginning, it was already done. This was already combined. So at the very beginning, we have x minus y minus 4. Right? That piece is finished. Then what did we have? Then we had this, which got FOILed out. And so that's x squared minus 2xy plus y squared. Then we have that, the blue part here, which is 4x. It should be a minus. My mistake here. Sorry about that. It should be a minus there. Minus 4y. And then what else do we have? Plus 16. Now we double check and make sure that nothing can be combined together. X, y, and 4 cannot go together, so that's done. We know we're done there. What about the next piece? X squared, no other ones. XY's nothing to go with it. Y squared by itself, 4x, 4y, and 16. Nothing else we can do with that. Okay. That one was, I think, one of the more difficult ones, just because keeping track of everything was hard. You had to FOIL, you had to keep track of it all. Most of the others are not that difficult. Question 9 is much easier. Squares are always much easier than cubes. So this one's going to be a walk in the park compared to the last one. Cubes are always difficult, squares are not. Now, how do I know this is a square? Well, let's think about what we have for squares. The only thing that we have for a square is we have a difference of squares. We can't do a sum of squares. Has to be a difference. So this is a difference. And then I look and I see the x minus 3y. Well, that's squared. And then 36 is a perfect square, right? Okay. So how do they go for the difference of squares? Remember your signs. Difference of squares is easy. Plus and minus. And we know 36 is a perfect square of 6 and 6. So we split this up, and so that's x minus 3y, x minus 3y, and we know that 36 is a perfect square of what? 6 and 6. So there's your 6, and there's your 6. That's it. So yes, squares are much, much easier than cubes. Cubes take a little bit of time to go through, squares do not. That's going to be your final answer on that one. And it just looks more intimidating than what it was. And I know it's squared because this is squared, and 36 is a perfect square. $18 is the last one that we're going to look at in this section, unless we have some more, before we start learning some new techniques. Okay, now, when I look at this one, this has 3 terms. All right, now if it has 3 terms, you normally take the first times the last. But this one, we can use a shortcut on. Because when I look here, at the beginning and at the end, what do you notice about 81? And what do you notice about 49? They're squares, okay? So 81 x squared is 9x and 9x. And then 49y squared is 7y and 7y. So this is a perfect square trinomial, right? Because it's all squared there. What's going to come down? Well, we know it has to be squared like that, right? It's a perfect square trinomial. What's the sign in the middle? Negative. And so what goes in here? 9x. For the first piece, the negative comes down, and 7y for the second piece. So all we have to worry about for the middle is just the sign. If this would have been a plus, then a positive would come down. This one was a negative, so it comes down. Why is this a perfect square trinomial? Because 81 is a perfect square, 49 is a perfect square. Now, last time we went through most of 5-3. We're going to go ahead and do some more out of 5-3. And then when we get to 5-4, it's all of them mixed up together. So 5-4 is no new material. It's just everything that we've learned all mixed up together. So I'm going to pick a few more out of 5-3 to look at. These are a little bit different on how to approach them. They work off of difference of squares, but you may have to factor first to get to that point. So I'm going to pick these from our textbook here to look at. Let me find a couple that do what we need them to do. How about we look at question number... I'm on page 361. We're going to look at question 25. So page 361, we're going to look at question 25, which is a little bit different than the last ones because we're going to have to approach it in a little bit of a different way. Now, normally when we have 4 terms, we try to factor it by grouping. So we group the first 2 together, and then we group the last 2 together. And that works most of the time. However, this one, we're going to have to group them together a little bit differently. Okay, so this one again has 4 terms. Nothing's in common. Now, I have something that is completely different. One part is completely different from all the others. These all have m's and that number 1. This n squared, is by itself. Okay, it's the only n there. So let's try and factor the first 3 pieces together. Because this is like what we just did a moment ago. This is a perfect square trinomial. Because when I look at these 3 together, I notice that 16m squared is a perfect square of 4m and 4m. And 1 is always a square and a cube. 1 is the square of itself. This is kind of putting all the pieces together that we've learned so far. We're going to factor this one out as a perfect square trinomial, and then we're going to have to do a difference of squares after that. So this is a perfect square trinomial. So it's going to come down as a 4m. The negative comes down, minus, and we said 1 was a perfect square of 1. Now we can look at this as something else. Okay, so we took the first 3 pieces and we combined those together. And I did that because that n squared was by itself. It's the only variable by itself. So it is unique there. So I looked at that by itself. Now when I look at it, this is a difference of squares, right? Because this is squared and so is this one. And we're almost done. Difference of squares goes minus and plus. You can put them either way. Just make sure one's positive, one is negative. It doesn't matter which one goes first. Then what do we have? 4m minus 1. 4m minus 1. And what about n squared? N squared we break up into n and 1. And n. So we first factored it as a perfect square trinomial. And then once we factored it as a perfect square trinomial, then we did it again as a difference of squares. And these get easier once you see where to begin. It's really not hard, the steps. It's just a matter of what steps do I do? And where do I begin? So let's do another one that's similar to that. That was 25. That was 25. Let's look at 27. Let's look here at question 27. And 27 is 4r squared minus 12r plus 9 minus s squared. Well, what looks by itself? What's going to be by itself? This s squared, right? Because it's the only s that we have. It's squared. That's by itself. Because eventually we want to get this to the point where we can look at it as a difference of squares. And also, what do we know here? Well, the first 3 pieces, when we look at those, 4 is a perfect square. 9 is a perfect square as well. It's all about squares. You look for squares. So, 4r squared is 2r and 2r, right? Perfect square. 9 is a perfect square of 3 and 3. So this, negative's in the middle, it's going to come down, and that's going to be negative here, quantity squared. 4r squared, we know we have a 2r, right? And then 9 is a perfect square of 3. So 2r minus 3 comes down, minus the s squared. Is everyone kind of seeing the pattern on these? 4 terms are a little bit trickier because there might be several ways to work them and factor them out. Now what can we do? Well, now hopefully you see this is a difference of squares, right? This is squared, and so is that. So we're almost finished here. Plus and minus. 2r minus 3. 2r minus 3. And an s. And an s. And there's your final factored answer. Okay. Let's try another one here. This one we're going to have to do it in a little bit different order. How about question 30? So question 30 is a minus k squared minus h squared plus 2kh plus 4. Okay, now with this one, we need to find the part that's separate by itself, and it needs to be a square. Now, when we look at this, we've got a k squared to match up with that k, so we're good there. H squared matches up with that h. But what we have that's by itself, that is a square, is this right here. Because 4 is a perfect square of 2. We always want squares, and that's the odd one out, because it's the only one that doesn't have an h or a k with it. To make this one easier, I'm going to rewrite this in a little bit different order so that it's easier to factor. So I'm going to rewrite this just in a different order as a minus k squared plus 2kh minus h squared. And then we've got the plus 4. I'm doing that so we have the middle to match up. See, it has the h and the k in it. What do we always need to do? Well, whenever we factor, okay, the very, very first thing that we do when we look at any type of factoring is we look at it overall and we see, can something come out? Well, in this case, it begins with a negative. And any time you factor something and it begins with a negative, no matter what problem it is or what type of problem, if you've got some type of grouping that you're working with and that first part is negative, a negative has to come out. And so I'm going to factor out a negative, and that leaves you with the k squared, a minus 2kh. Negative and negative makes it a positive h squared. It doesn't come out of the 4 because the 4 is all by itself back at the end there. So it's okay. Now what can I do? Now we look at this. No numbers there, but what do we know about k squared? Perfect square. What do we know about h squared? Perfect square, right? Always look for squares. So that means this is a perfect square trinomial. The negative is going to come down. And that's k. And that's h. And the negative is still out front. Right. Now, the way it looks right now, we don't really see that it's a difference of squares, but it is. So let's rewrite this. So it looks like something we're familiar with. So put that 4 in front. Now you can definitely tell what it is, right? We just rewrote it so that 4 was in front. Why did I do that? Because now we can see that this is a difference of squares because it's a difference there. And we know that 4 is a perfect square of 2. Right, so it's all about rewriting, looking for patterns. Factoring is nothing but a puzzle. Figuring out what to do with each part and each piece and how to approach it. So it's kind of a game, kind of a puzzle. So we first looked at this and I said, okay, that 4 is by itself. Now, why did I say that 4 is probably by itself? 4 squared. So that when you look at things, you got to see where to begin. And I look for squares and I try to figure out on these type of problems that have 4 parts, 4 terms, what goes where. And I say, okay, that is a square, right? That 4 doesn't have an h or k along with it. These all have h's and k's. And those 3, if I rewrite it, looks like this, which is something we're used to factoring, because that's squared and that's squared. Always if it begins with a negative, pull the negative out. Then we know that this is a perfect square trinomial. Right? Because h squared and k squared are both perfect squares. We bring the 4 down. Then I rewrote it because this doesn't look like anything that we're used to. So I rewrote it with the negative in the middle. Now you see that this is a difference of squares. Right? Because 4 is a perfect square. That's what we wanted to get to eventually was get to the difference of square part. So now let's rewrite this as a difference of squares. We have plus and we have a minus. Difference of squares. And so 4 is a perfect square of 2 and 2. Now with the difference of squares, we have to be careful with the k minus h because that negative is going to have to be distributed through over here. So the first piece is simply k minus h. The second one, use the parentheses because that negative in your difference of squares has to be forced through. And so now, after we're completely finished, it's going to be 2 plus k minus h, 2 minus k plus h. And that is your final, fully factored, finished answer. And it does take a little bit of skill to get used and practice of doing these, of seeing what the pattern is. Because get in your mindset to look for things like squares and cubes. Look ahead of time and see, okay, what do I think I can manipulate and move around to make it work? The ultimate goal is to get it to 2 sets of parentheses like this. That's what we normally want to try for, is something like this. This is factored, where we have 2 sets of parentheses. You might have something out in front, but this is the ultimate goal, to get parentheses and reduce it down. Factoring reduces it into an easier to work with form. Because what we're learning is how to factor, but in college algebra, you're going to have to factor and solve these. So in college algebra, we do the factoring, but we do one more step of solving it after that. Let's look at one more of these, and then we'll take a short break. Let's look here. A fairly easy one. Let's look at question 71. We've got t to the 4th minus 24, t cubed, minus t minus 3. Okay. Now, we are going to begin on this one a little bit differently. Why? We don't have any squares, really. 8 is not a perfect square. 24 is not a perfect square. 3 is not a perfect square, right? So we can't do it like we did the others because we don't have any squares. We don't have any cubes either. I mean, 8's a cube, but 24 is not. 3 is not. So we need to approach this one a little bit differently. Now, when we do factor by grouping with 4 terms, we either group it in groups of 3 or in groups of 2. Let's see if we go back and we think about these grouped together. Because I want you to kind of think about looking ahead. What would happen if I took the t cubed out of here? And the 8. Okay, if I took the t cubed and the 8 out, that is going to leave you with a t that's going to match up with that one. Right? And what's 24 divided by the 8? If I took an 8 out of here, 24 divided by 8 is what? 3. See, it's going to match up. You want things to match up. So that means that we're probably going to be able to factor it in groups of 2. These 2 and these 2 put together. So let's take out an 8t out of the first 2 pieces. 8t cubed, because that'll take care of our variables here. And 8 divided by 8 is 1. We've got 4 t's. Take out 3. That leaves you with a t. 24 divided by 8 is a 3. Okay. So that goes there. Now what do we have next here? Oh, and that should be a plus there. My mistake. I copied it down wrong. Yep. It's going to be a plus there. And notice now, what do we know? This already matches up with what? That. If nothing comes out, what can you factor out? You can always factor out a 1. And that leaves you now with the t minus 3. These are the same. So that's t minus 3. And then 8t cubed plus 1. So that's kind of what we did last week when we did factor by grouping. But we are not completely done yet. We always have to check to see if we're done. And we're not completely finished and done yet because look at what I've got underlined. Well, there's 2 terms there, right? And it's a plus. What do we know about 8? Is 8 a perfect square or a perfect cube? Is 8 a square or cube? 8's not a square. 8 is a cube, right? Remember, go back to your table of cubes. Always try to keep that handy if you need it. 8 is a perfect cube. So 8t cubed is going to break up into 2t, 2t, right? And 2t. Because this can go one step further because this is a sum of cubes. T minus 3 is simply going to come down. This is a sum of cubes. Remember how the signs go. Plus, minus, plus. And now we fill them in. And we know that 1's a perfect cube of 1. Right? 1 is always a square and a cube. So 1's kind of one of those things we need to remember that it goes with anything. So let's remember how these go together. Okay. 2t goes out in front. Gone. What's left over? 2t times 2t, which is 4t squared. Right? We multiply because they go together. They get multiplied together. And then what's here? 1, because that's gone. And what's left over? 1 times 1, which is 1. And then what goes in the middle? Those 2 put together, which is 2t. And that is now our final, finished, factored answer. We broke it down as far as we possibly could. Cubes are never going to go any further. So this part right here, this trinomial, never goes any further. Okay, it's not going to go any further. Even though that's square and that's square, that 2 messes with it. Anything that comes off of a cube is not going to factor out more. That trinomial is done. So let's go ahead now and take a short break. We're going to come back and we're going to look at 5-4, which is all the parts put together. It's the same questions we've done from the very beginning of this chapter, just all mixed up. So let's meet back here in about 15 minutes. So let's meet back here at 9:45.